Welcome back to our course. So in this session we fine-tune the default parameters of our optimizing function that we created before, and our optimizing function should actually work in every case, so irrespective whether we are on the steep or on the flat side of the curve which we plotted here. So here's the steep part of the curve, and here's the flat part of the curve. And also we should be able to change the album capacity, so the optimizer should actually work for every album that we can think of actually. Alright, so let's start with our, let's say, base case. We have our album with a capacity of 600, and our target is to get 550 stickers, because it's our best strategy to just order the concrete last 50 stickers, which is possible in the most cases. Our random start is 800, and let's see what we get. So we get here, we need 1480 stickers that we reach in the end 550 unique stickers. So this works, but what if we change our target here, and let's say we change our target to 300. Yeah, and there you can see we are getting a nonsense result. And to better understand why we get a nonsense result, we should print the intermediate results. So we enable here the print and change here our optimize function and run it again here. And there we can see, so we started with random stickers of 800, and we were quite far away from our target. So target is 300, we were at 450. And with the learning rate of 7, we changed our random start by 7 times 144, so we end up with a negative random start. And a negative random start results in 0 unique stickers, which is also very far from our target. And then we jumped to a random start of 1800, which is even more far away from our target then. So our result is 475. And the difference is 275 from 300, so we end up with again a negative random start. So actually here when we look at the graph, we jumped here back and forth from negative to the very flat side of the curve, but we never reached here the spot where we wanted to be. And the reason for it is simply that the learning rate is too high. So we have a learning rate of 7, and here in this case we should reduce it to let's try 2, and there we are. So we started at 800, and after 4 iterations we end up at a result of 300 unique stickers, and for 300 unique stickers we need on average or on expectation 420 stickers we purchase. Alright, so let's go to the very flat side of the curve, and let's say our target is 595, so very close to our capacity of 600. We set random start to 800, learning rate is 7, and the amount of iterations is 20. Yeah, and there you can see, so within 20 iterations we do not get to our target of 595. Because here we end up at the very flat side of the curve, and even if we here increase our purchase stickers, there's not too much change on our unique stickers. So now here we have 2 alternatives. So either we increase the learning rate, so now here we end up at 2860 stickers we need to purchase. So even we increase the learning rate at the very flat side of the curve, or we increase the amount of iterations. So instead of having only a maximum 20 iterations, we can increase it to, let's say, 50. And here we also reach our target. So with our tolerance of 0.5, we get 595.6, and our result is 2686, so it's the same as here. So there are 2 alternatives. Either we increase the learning rate, or we increase the amount of iterations. So in both cases we started at the random start of 800 here, but what if we set our random start to 3000? So we start at the very flat side of the curve. So before we started here at kind of moderate part of the curve, but now let's start at the very flat part of the curve, and let's see what we get here. So again, our target is 595, and we only changed the random start to 3000. Yeah, maybe we can also change the learning rate already to 10, because we are on the flat side. And there you can see we get, after 12 iterations or something, we get also a result of 595.2 unique stickers as expectation. But the algorithm says that we need 2835 stickers to reach our target. So we are actually at the very flat side of the curve, and yeah, only a slight increase of 0.6 unique stickers gives us a difference of about 200 stickers we need to buy. And so now if we are starting at the very flat side of the curve, starting point 3000, yeah, actually the algorithm overstates the amount of stickers we need. So we should always come from the more steep or moderate part of the curve in order to prevent that the algorithm overstates the amount of stickers we need. So actually introducing a really random start might be not the best idea. So we have to make sure that the random start is not so random, and let's say, depending on the album capacity, let's introduce, instead of having a random start fraction of 80%. So what does it mean here? So this, we introduce also this line here and say, okay, our random start is actually 80% of our album capacity. So we make sure that we start at a kind of a moderate part of the curve, not too steep and not too flat. Alright, and also we learned that our learning rate of 7 might be a bit too high, so we reduce our learning rate to 4, and the maximum amount of iterations of 20 might also be quite low. So we increase the maximum amount of operations to 100. So that's the 3 changes we want to make here on our optimize function. So we make sure that the random start starts at about 80% of the album capacity. We're reducing the learning rate to 4, and we are increasing the amount of maximum iterations. Yeah, and there's always the trade-off. So now in our base case with target 550, we might need a bit more iterations to come to our result. So before at learning rate 7, we only needed 4 iterations. So let's try this out. 550 and learning rate 7. So we needed here 4 iterations. So now if we change the learning rate to 4, our new default setting, we need 5 iterations. So it's getting a bit more inefficient. However, on the other hand side, the algorithm should be effective for all cases we can think of. So there's always a trade-off between efficiency and effectiveness. Alright, so let's now make a stress test of our new algorithm and check some extreme cases. So first of all, we set our target to 599, so we are on the very, very flat side of the curve, and also we set learning rate to 10. So we are still not there at our target. So now we have to change our optimize function. So far we only changed the parameters, but we didn't run it, so we have to run it, of course. Now let's try the extreme case of 599 as target. So now here we end up with 598 as expected unique stickers, and we need 3,279 purchase stickers to reach that result. Okay, let's go to the moderate point of the curve. So our target is 550, learning rate can be the default value of 4. There we are very fast, and also we have to check whether the algorithm works at the steep point of the curve, so we set our target to only 10. And there you can see we are ending nowhere, and so we have to reduce our learning rate to, let's say, 2. Also no result, so let's take 1. And there we end up after 4 iterations to 10 actually. So in order to have 10 unique stickers, we need to buy 10 stickers. And also let's variate the album capacity. So let's say we have a very small album of only 20 and let's move to the flat point of the curve. Let's say our target is 19 and we set tolerance to 0.2 and let's check whether the learning rate of 4 works. Yes, it works. So we need 54 stickers. And let's check also the moderate point of the curve. So our target is 15. And also this works after 4 iterations. So in order to get 40.8 unique stickers as expectation, we need 27 stickers. And we can also move to the steep point of the curve and set our target to only 3. And let's check if learning rate of 4 works. No, we are getting nowhere, so I think we have to change the learning rate to 1. Yeah, and there we get 2.8, so it's not getting better, so maybe we can also increase here the simulations to 10,000, so we can do it. It's only a small album, so there's not too much simulations and calculations. So here we end up with an expectation of 2.8 unique stickers with 3 stickers actually. And we can also check if our algorithm works for a very large album. Let's say we have a capacity of 2000 and we start at the very flat part with 1990 as a target, and let's set the learning rate already to 10. We are already quite close to 1990. Yeah, and there we are. So with 10,575 purchase stickers, we expect to get 1990 unique stickers. And let's check also if the moderate part of the curve works. So our target is 1800. And after only 7 or 8 iterations, we end up with 4,598. And let's check also the steep part of the curve. So target is only 100. So learning rate is here 4. As we are on the steep part of the curve, we should reduce our learning rate to 1. And there we are. After 6 iterations, we end up at 103 purchase stickers and an expected unique stickers of 100.2. So actually our algorithm, obviously works for all extreme cases. So let's go back. This is our algorithm. Let's copy it. And let's again paste it here. So now we can cross out the printing of the immediate results. And let's check again. So let's assume we have an album with capacity of 376 and our target is 326. And we use 1000 simulations and a small tolerance of 0.2. Let's check. So now we use quite a lot simulations. So this should be a very robust result in the end, and we end up with 756 stickers we need to purchase in order to get roughly 326 unique stickers. So we could manage to fine-tune our algorithm in a way that it works in any case you can think of, and the only thing a, let's say, informed user has to know is actually that the perfect learning rate is in the interval 1 to 10, whereby in most cases the default value of 4 works quite well, and if it's not working, you should carefully increase or decrease the learning rate until it works. And as a general rule, the more you are at the steep side of the curve, the closer you are to a learning rate of 1. And the more you are on the flatter part of the curve, the closer you are to a learning rate of 10. Also, in addition, we could also introduce a learning rate that adjusts itself depending where we are on the curve. But that would be the perfect solution for the totally uninformed user. However, well, I think at this point this would be a bit too much over-engineering. So now we are finished with our sticker album challenge by using the Python standard library. So we have here our sticker album function, which calculates the expected amount of unique stickers given the capacity of our album and the amount of stickers we want to purchase. And also we have our optimize function to solve for the amount of stickers we need to purchase in order to reach a certain level of completeness of our album. And also we figured out that ordering the last 50 stickers number by number, which is in many cases offered by the album vendors, a very good idea, because otherwise we need to buy hundreds or thousands of random stickers more to complete our album, because we are on the very flat side of the curve here. And by ordering the last 51 we can save a lot of money. And there's much more to analyze. For example, how and to what extent does it help to trade and exchange duplicates with others? And this question and many more we will answer when we recode our challenge here with NumPy code, which is much faster and allows us even deeper analysis. So I hope you enjoyed it, and I hope I see you also in the NumPy section. Bye.